Only in West Virginia.
Okay, so it's easy to turn in both directions. Okay, so what you're going to do is you're going to take a simple paper clip. It can't be a coated paper clip. It has to be a non-coated, regular old, boring paper clip that your grandma has laying around the house or whatever. And you're going to short out the black and the red wires. Now I need someone to turn the pulley.
Clockwise or counterclockwise, sir?
Yes. I'm going to turn it the other way. Harder, isn't it?
That definitely is harder.
Okay, so he's going to tell you why.
Why, sir?
Oh, because you're creating induction, or you're creating electricity.
You're creating power. You've turned this into a generator.
Spin it from the other side.
DC
That's
generator.
cool.
That's about the same resistance.
Way.
Yeah.
Anyway, you're creating power.
Cool.
The problem is when you're creating power, you're shoving the power into other power, and you're basically deadheading it. You're putting even and opposite voltages on it. Okay, so even though you check this thing with a voltmeter or an ohm meter in this place, because they're not actually checking volts, they're checking ohms, you should always take your paper clip and you should always check this in both directions. Believe it or not, I have had motors where it passes all the checks, and you can turn it in one direction and it's really hard, but you turn it in the other direction and it spins just like this. And even though it passes all the checks, there is something wrong with the internals in the motor because it didn't spin hard in both directions. Now, the other thing is you can check this motor with it still being in the balancer, right? So if you have this thing in the balancer, you haven't taken anything off, you've taken the top off, you've unplugged this from the DC drive, you're just going to, you're going to do all your check. And by then, there's a pulley, right? And then you're trying to turn the actual spindle, which is on a pulley, which has a force multiplier. So it's actually even harder to turn the pulley because it's at this point you're overdriving because you have a big pulley and a little pulley over here. So every time you try to turn it, it's actually even harder to turn the actual spindle, okay? So now your paper clip is now a diagnostic tool. So now your office supplies are diagnostic tools because all you're doing is you're taking a paper clip, which seems innocuous, and turning it into a very important test. Okay? All right. I know, right? Just like me. Thankfully, the print shop has some. Where's the DC drive board out of this particular unit?
On the desk over there.
All right, I would love to have the DC drive here. That's the DAQ board. I'll take the DC drive board.
No, there's this one right here.
Oh, you didn't take the DC drive board out. That's all right. Somebody give me a DC drive board. That one's fine. It's not the right one, but it'll work. I'll take it. Okay. The DC drive board. The DC drive board is going to tell you that it only makes 240 volts. No, it doesn't say 240 volts. Input, continuous 8 horsepower peak. Armature, 0 to 240 volts. Okay. So I just read to you that it makes 240 volts DC. I'm going to tell you that for some reason that sticker's not right, because when I go over to the brainy guys over in Balancer Garage, they're going to tell you that this is a 380 volt DC drive motor. Okay. Either way, if it's 240 or 380, this thing makes 8 amps. At 240 volts DC and 8 amps, it will still unalive you. And we don't want that to happen. Well, maybe depends if you keep doing dumb things like that. But because of that, we will never ask you to measure anything on this board. We will never ask you to measure ohms. We will never ask you to check voltage coming out of the board. So the only way to know that you have a bad board is you have to make sure 100% you have a good motor, right? Because the board gives the voltage to the motor. If I can't check the board, I have to be able to check the motor 100%. If the motor checks out and it still doesn't spin, then unless you're not getting a signal wire, you have a bad drive board. Okay? So again, the lab's never going to ask you because we don't want you to have something slip and then you're arc welding onto here, or you're actually. You ever watch some people take a? I love people who do this with the leads, and they take the leads and they decide they're going to hold the lead way down here, and they're actually holding the lead rather than. That's why they put the little bulbous thing on here to keep the dumb people alive. But some people will hold the leads to try to get it to where they're going, right? At that point, you're just touching 8 amps and 240 or 380 volts. That's really not bad. So again,
Fuses on there?
I'm sorry.
Maybe check the fuses on there.
I don't. So I would take a pick and pull the fuses out and just check the fuses for continuity at that point. But I'm not checking voltage across the fuses, right? And you can't obviously check resistance across the fuses because it'll just backfeed through the whole thing out, and you get like 10 million amps from 20 to 10 million ohms. You'd be like, well, I guess it's good. Again, if you notice, these things are white because they're ceramic. We love our ceramic fuses because they seem to last a long time. The other thing with a good ceramic fuse is, unlike a glass fuse in a car where it's a fast-acting fuse, these are slow-acting fuses. These are what we call slow-blow fuses. It takes a while for them to heat up, really get upset. And it's like your wife. She's got to get proper mad at you before she lets you have it. So same thing with the ceramic fuse. Okay.
You ever met my wife?
0 to 100.
She's a glass fuse.
This is
She's a pistol.
see, these say 400 volts, 560 microfarads. Lovely, and there's 2 of them. So we don't want you touching anything over here. The little black, you can either call it an Oreo cookie or a Thin Mint. That is actually a thermistor. So if the board gets too hot, the thermistor will sacrifice itself and open up, and then the board goes bad. The other reason, if you notice, we put some hot glue on it, because this thermistor here, because it's a balancer and it's vibrating, the Thin Mint will just sit here and flop back and forth until it breaks one of the legs, and then you vaporize the leg, and then you still don't have power on it. Okay, so you got your Thin Mint, which is your thermistor. You got this little cool box right here, which is where I'm going to tell you it takes the voltage and pumps it up to 380. Because I've always heard it's 380. Okay. Does anyone have an older board that actually has colored LEDs? No.
That was probably the oldest machine that.
Open up the first cabinet right there and look for a board that looks similar to this.
That's.
Yeah, we got one here. I'm sorry, Brandon.
Oh.
Jared here had Jared's got one. He was working on East Texas time, so he was walking at 40%. So I had to wait for him to get over there. Older boards have older boards, a long time ago, it was really hard to make colored LEDs, so it was easier to make a white LED and put a little Noid light guy over it to make red or green. We still have LEDs on the board, but now we know how to make colored LEDs. So now this LED is either red or green depending on the actual LED. We don't have to have a white LED with a cover over it. Okay. Okay. The other thing, this board is green. This board is blue. If you notice on here at the end of the LEDs, there are trouble codes on it. If you notice here on the end of the fuses, there are trouble codes on it. We will. You have to go back to 1983 when you put your paperclip into your ALDL, because it wasn't a DLC back then. Your ALDL connector, and you counted the blinks. Okay, unlike a car, we will never blink anything but a single-digit code, and we will never blink more than one single-digit code. We're a very simple company. So we do have the ability to blink a code, but again, it's going to be somewhere between 1 and 9, and we will just repeat that one code. We don't have multiple codes. You don't have to worry about it. You still look for the bigger pause, right? Because you have to know when to count, if it's a 5, a 6, a 7, or an 8, and then it'll have a bigger pause again, and it'll just keep blinking that. Unfortunately, we don't have history codes. So if someone unplugs it from the wall, the code goes away. So if the guy is trying to help you and he's trying to help you, I turned it off, I unplugged it from the wall to reset it, and it started working again. Well, that's fantastic, because unfortunately we deal with car people, and car people have history codes, and they go, well, can't you just go into the history and look the code up? No, I can't. I'm good. The biggest ones you have to worry about on that, one of them said breaking something. The
Break
6 or a
error.
7. Is that a
Number
6 or a 7?
number 8.
That's an 8 on that one.
There's break T out and break error.
Okay, what's break T out? Is that 6?
7.
7. Okay, break timeout. That's a 7. What's a break timeout on the blue board?
I have break error as number 7, and that's all.
Okay. So number 7. Number 7. That is the only code that is a hard code. If you unplug it from the wall and you plug it back in, it
It'll
will
stay.
continue to break an error 7. The only way to get rid of an error 7 is to replace that board. Okay, so once you get an error 7,
It's chopped.
it's done. Okay. It's called a break timeout, which means it took too long to slow the tire down. Okay.
Do the error codes, do they blink continuously, or are they only on power up of the system? Like, does the LED, does it only blink once you press the power button and then go away, or is it continuous?
If there is an error code after it powers up, it will continue to blink that error code
Okay.
forever. Now the problem with your thing is if you shut it off and you turned it on, there won't be any error codes because we forgot them all.
Okay.
The only error code that will persist is a 7. So if you turn it back, it won't blink when it's off. But when you power it back up, because it's a break timeout, it will continue to blink the red light 7 times. Can you, I know we don't have one of these loose. Can you look back in that first one? You're looking for a giant yellowish orangish resistor with 2 black leads. It's about 1 inch wide by 2 inches long and has a black lead coming out of each end of it, and it's anodized. No.
Man, they had fun with hot glue on this one.
They cooped it all up. Yeah, they cooped it all up.
Even at the base of it.
Well, because we don't want those. We can't have breaking timeouts. If you notice, all of your DC drive boards had 2 black wires coming to them. It doesn't really matter which way the 2 black wires go on because it goes to a resistor. The resistor is a resistor. The resistor does not have a diode in it, so it doesn't matter. Polarity doesn't matter. Okay, so this little orange, if you want to call this guy yellow or orange, I'm not really sure what color you want to call this guy down here. It's anodized. It's aluminum. If you notice, it is bolted to something much bigger aluminum-ish or steel. That's because it's a heat sink, right? So what's happening here is, if you notice, it says 57 ohms or 57 omega signs. I don't know if omega signs or not. So we have 57 omega signs. This is our braking resistor. This helps slow the tire down. When we put resistance on slowing the tire down, resistance creates heat, so we have to have this big giant heat sink on here. Otherwise, one end of this thing will act like a piece of Orville Redenbacher, and it'll just take this end and yeet it out until the wire stops it, and then it'll bring it back. Okay, so when you buy a DC drive, you have to order it as a kit because we give you a DC drive and a braking resistor. It's easier just to give you a braking resistor every time you need a DC drive. Now, for those of you who are competent enough to measure in omega signs and you feel confidence in your confidence, you can just measure out 57 ohms of resistance on your wires because it's either good or bad. It's not like you can be halfway. And then if you want to, you don't have to replace the braking resistor because you just checked it. Make sure it's good and tight. Right, the German version,
Good and tight.
that one. Make sure it's nice and flush. Make sure there's nothing in between it because I need the heat dissipation.
Do they use heatsink paste behind it, or is it just hard?
No, it's not like a CPU. It's not as it doesn't get as hot as it doesn't have thermal paste. It's not like a CPU. We just need the actual physical contact. Okay. A lot of times, your error 7, your break timeout, is something just went wrong with the board. So first thing I do is I just check my resistor. If the resistor went bad enough, you will see one part of this thing just flopping around over here, and then you know you have to replace it. Where we put these resistors, if you notice where that resistor is and that one, and that resistor is in that one, and that resistor is in that one, it's in a hurtful spot. I think we start by putting the braking resistor in space, and then we build the whole entire balancer around it. So if I can save myself a lot of agony and a lot of pain, especially if you have big, thick sausage hands, trying to get into where there you go, big thick sausage chamber. You're trying to get to this braking resistor is not exactly, easy. So again, if you measure out 57 ohms, excuse me, I keep saying 57, 75. 57, 75, I'm dyslexic. Anyway, it says right on the thing what the ohms value is, 75 ohms. If you get to the right ohms value, 75 instead of 57, sorry, it's good. Yeah, again, you're going to replace it with another good one. Okay. Something happened in the DC drive. It popped a 7. It's going to pop a 7 until you replace it. Okay. What happened to that green board? There you go. If you notice, this and this looks a lot alike. That's because this is for newer balancers. This is for older balancers. The older balancers drive board was ginormous back in the late 90s. So if you notice, this board here just sort of sits like this. And that's because that board just sort of sits there like that. So if you want to order in a whole kit, to have a kit on the truck in case you have really old balancers still, because some of you are going to have really old balancers, depending on the rurality. I made that word up on the fly. Depends on how rural your area is. If you're in town, they probably don't have a lot of older balancers. But if you have more cows than cell phone towers, odds are you're going to have some older balancers. Okay. If you order the whole entire kit, you will get a box. Okay. Now you can take the board out of the box. Like if you have a newer balancer and you need a DC drive, you can just steal the board out of here and then just order in a DC drive, and then you can have a good working box again. Okay. We went from this to this.
But you can retrofit the older machines with the new kit.
Yes. So, and we'll go over the history of DC drives here in a minute. But yeah, so this stops at generation 2. Once you get to generation 3, we just use the boards. Okay. The other thing, the blue one. So we make green boards and blue boards. I particularly don't like the blue boards. I don't think the blue boards is good. They just don't seem to work as well. There is no way for you to call and ask to get a green board. You're going to get whatever we decided to pick up that day and send to you. Okay. If you do get a blue board, you sort of sigh a little bit and you put it in anyway and you go about your business. Okay. I don't know, we just had 2 different manufacturers. Okay. While we're talking about boards, this board here has not a dip switch but a shorting bar, and it has 3 pins. There are no instructions on this board. This board, however, has a shorting bar, but at least it has instructions on it. And it says pins 1 and 2 is old and pins 2 and 3 are new. Now the good news is that pins 1 and 2 on here are old and pins 2 and 3 are new, but we don't bother to tell you that on the board. You have to actually look it up on the paper instructions. Okay. So you're asking yourself, well, what constitutes old and new? Well, thank you for asking. That's so nice of you to ask. Generation 1 and 2, if it's an old balancer with the old box, that's old. Starting with generation 3, which is kind of nice because it's pins 2 and 3. Starting with generation 3, it's the newer. So you'd have to put the jumper pins from old to new. Okay. If you forget to do that, it doesn't blow anything up. It either A, doesn't work, or B, gives you an error code 4. And an error code 4 is usually an internal memory fault, which means you're going to replace this again for a second time because you think you have an internal memory fault. And the only reason it does that is it has something to do with the clock speed. And the clock speed is too fast on the new for how old and ancient the rest of the balancer.
It's a turbo button.
It's like a turbo button. So if you leave it on new in an old machine, it just doesn't work. Good news is you can just unplug it from the wall, move the shorting bar over from old to new, or new to old, and it will start working like not a problem. Okay. All right. So I don't know why we did this. For some reason, for the resistor, we have the word dB. I'm not sure why we use the term dB, but then we have L1, L2, and then we have motor leads. Motor leads are A1 and A2. Okay. Some balancers spin the tire clockwise. Some balancers spin the tire
Counterclockwise.
counterclockwise. Do you use counterclockwise or anti-clockwise?
That's a good question.
Okay.
I think the word is counter and anti, same thing. But
Yes,
yeah.
but some places in the world don't say counterclockwise. Some places in the world actually say anti-clockwise.
Yeah.
It's funny to me because I don't say it that way, but there are places that say anti-clockwise.
So that's a
rather
good
than-
question because I hear my dad using the counterclockwise. He's
Yeah.
from Guyana, and I'm from
Okay.
Trinidad, and they use anti-clockwise in Guyana.
That's cool.
So-
The things you have to
so-
know as a teacher.
So you might hear my dad using counterclockwise, and
Okay.
you might hear me using
Anti-clockwise? Okay. Yeah, but that's
Yeah.
neat.
Yeah.
Little cultural things like that, right? Cool. We're now cultured people. Alright. The good cultured, not the bad cultured in like a petri dish, right? We're good cultured. Right? We don't want like low cultured. Yes.
You want to save these off the old boards, correct?
The new boards come with one.
With the shorting,
You can save them.
don't they help you do something with the scissor list?
The scissor lifts come with 3 or 4 of them that you can strategically borrow anyway. The one place you will need it is for the Revolution because you need to short out a S1
To get
to
it.
do the self test. So if the first couple of times you want to save some shorting bars, that's fine. A1 and A2, back to counterclockwise versus anti-clockwise. You put the red in because it's DC, right? So if you just put the red and black wires on backwards, when you power up, when you go to A1 and A2, the balancer may spin the wrong way. The good news is the software is smart enough to know that the balancer is spinning the wrong way, and it's going to give you an error message like unexpected reverse direction, whatever. Okay? Detected.
Oh.
Basically, that means you plugged up the red and the black wires the wrong way. So you're just going to unplug it from the wall, take the red and the black wires and switch them around, and then it'll turn it in the proper direction for whatever balancer you're working on. Okay. If you can't do it just by double tapping the pedal because the double tapping the pedal it just sends voltage to the motor. You have to pull the hood down like you're going to spin a wheel, right? Because then direction matters when we're spinning the wheel, right? But if I just double tap the pedal, it'll work all day long. It'll take it off, it'll put it on, take it off. Because it doesn't care what direction it's going in, it just reverses it.
It's not taking any measurements yet.
Not taking any measurements yet.
So the other is that somebody was saying it was made in Germany.
No, we're saying it's gluten tight.
It's a paraphrase.
Yeah.
Right? You either have tight or you have German tight, and German tight is Guten tight because it sounds German.
Yeah.
Right, so,
So when you put the old, twist the old forearm a couple of notches.
yeah, you ratchet up the tension so that your wrist doesn't pop until it's really tight, rather than halfway tight. And you get the arthritis in there and it pops it. You got your own torque wrench at that point.
The wristometer.
Brakes at the certain rate. Okay. DC drives. Okay. You have to be careful with the drives. This drive here will fit in any. This drive here will fit and work in any of the balancers. This drive will not work in a Road Force Elite. The Road Force Elite has a different part number for the DC drive. Speaking of a turbo button, the DC drive in an actual Road Force Elite has what's called turbo mode. Okay, because when we went to the Road Force Elite, we were told we had to make this balancer X amount of percentages faster than the old one. So when we're doing a straight track measurement, it spins this way and then it has to stop and then it has to start spinning the other way. Well, the old DC drives, it would slowly spin up. So what we did is we gave this turbo, well, not this one, we gave that one turbo mode so that it can get up to 300 RPM faster so that we can measure tire pull going in the opposite direction. And that saves us like a second and a half, which equates to 5% faster floor to floor time, so that we can say this balancer is X percentage faster than the old one, and we can meet the goals set forth by us by our owners and our vice presidents. So, technically, you can use a turbo mode one in anything. It's just these guys won't use the turbo mode. But when it's in a Road Force Elite, the software knows it's a Road Force Elite, so it's going to try to use the turbo mode. If you have a older DC drive that doesn't have it, you're just going to get an error code. Okay, but it is a different part number.
So-
It looks nearly the same.
Well, then why would they continue to make those boards if that one's backwards compatible?
Because we're engineering.
Okay. Fair enough. I mean, you think it would save money, right? Instead of
Well,
continuing to
you'd-
produce a board
you'd
that
have
only
thought,
works.
We'll have to look up the price on it and just
Yeah.
see if it's like egregiously more expensive, like the spindles.
But
I
if it
just-
is, I'm sorry, if it is comparable in price, it would make sense just to stock the one. Yeah.
The one, because it'd be backwards compatible for every other.
Yeah. Now I'm interested.
Makes a lot of sense. Instead of having two different boards on the
Right.
truck, just one.
Lighter inventory.
Tell you what, we'll look up that DC drive for the Elite and see what kind of. We'll go into price lookup and we'll hit more info and we'll see what it says because it'll spell it out. We'll spell it out there for us. Okay. What else? Talked about resistance. Talked about boards. We need to break out the boards and talk about. Well, you guys need to. I guess you guys need to see them just to need to see them. So this one's yours. This one's.
Belongs in
Put
the
this one
cabinet.
back in the first cabinet. I need to. So if you go down and bend down just a hair, that drawer there. Okay, I'll put that one back on the upper left. Grab the really big DC drive on the right hand side of that board. It looks like a parking lot to an airport. It's about a foot long, 6 inches, 8 inches wide, 2 inches tall. Yeah, that one. There you go. I'll take that one.
That's kind of important.
So, this is our original DC drive, which is why we still have to have the box because of the mounting holes. Right. So on the old balancers, we had really spread out mounting holes, and again, back in 1997. Electronics was a lot bigger. We didn't know about microcircuitry, and we did, but it was tragically expensive. So this is what a DC drive looked like back in the day. We have 2.5 braking resistors because we still had to get the 75 ohms, but I don't know if we decided that more air was better to cool it off or whatever. We have the giant heat sink on the back side of it. We have once again we have big capacitors. We have a big. This is a voltage transformer because it's big.
That's the same thing the little black box does.
Yeah, the little black box does this now, right? And then here's just a giant heat sink. This thing, I was gonna say, with a 3-legged transistor on it, right? So we're trying to keep this. Whatever this transistor is doing is getting hot because it's attached to this giant heat sink right here. We still have the same ribbon cable. If you noticed, all of the DC boards have the same ribbon cable connector because we have to be able to backfill orders, okay? This one had some Noid lights on it. We don't have to worry about the Noid lights. And then this is where your motor drive would get plugged into. Okay?
Look at all the wrong boards that thing has to have on.
Oh, I know, right? There's just crazy amounts of stuff on that bad boy right there.
Processing power of a calculator.
Yeah.
Maybe, yeah, if you're lucky.
And so here, this will make you uneasy. This is a revision S. So someone figure out what letter S is in the alphabet 2021. Something like that, right? So this one that I'm holding had already undergone 21 or 22 revisions just to get to this. And then we finally decided that we couldn't make this anymore. Or this company, the people we bought this from, may have finally gone out of business. Although the board says Hunter on it, so I'm not sure. Evidently, we just decided we could make it smaller, better, like the reverse $6 million man, right? We could make it smaller, better. All right, thank you for that. It's huge and it's heavy.
Which that thing, when it let the white smoke out, you really knew it.
Yeah, it was good times.
Did you actually repair, like, seeing how those electrics are so small, how do they actually repair those resistors and those,
We don't.
yeah, baseboard?
Yeah. So I don't. You might have not been in here this morning for whatever reason, but Hunter's diagnostic path is you get to a known. Hunter's diagnostic path is you diagnose something down to the component. If you think that component is bad, you put in a new component. If that component didn't fix it, you take that component out, put the old one back in, and then keep diagnosing until you get to the next component. And then you just look for, whatever that next component is, whether it be a spindle or a motor or a drive board, right? So this isn't rebuildable. This isn't rebuildable. The drive board's not rebuildable. We replace pieces, like entire.
Components.
I don't want to keep using that word.
And if you install
Hard parts,
something
large assemblies.
and it's it's still good and it's brand new, you could just send it back. You get a refund.
He's international.
Oh yeah, maybe not. That's right.
He might be. He licked the door handle on that one.
Yeah.
That's another thing to ask Eduardo.
My rep mentioned that he changes brushes. Like we swapped out a motor. when
Yes,
we
you
were out.
can replace brushes. So brushes on this one. Brushes on this one. Give me a straight blade screwdriver. Thank you very much. So, hey, look, freaking perfect. Brushes on this one. This one here, you just unscrew the brush holder, and then the brush pops out. This brush is kind of weird because it's all self-incorporated. Older motors, the brush had like a solderless terminal on it, where it was male, female. This one here has the spring already on it, and then this actually touches the case. This actually touches the special part of it, commutator. Thank you. It touches the commutator. Okay. The problem you get with these wires is if the wire here in the middle, if the little brass wire there, or copper, if the little copper wire in the middle sticks out the end, this brush can't bridge the gap on the commutator, so it can't hit the two pads. So the brush will actually like arc weld itself, and it'll make a nice ring around the stator, and then that motor's junk at that point. Okay. Again, for those of you, I've said this a couple of times before. We are an a la carte company. If you forget and you only order one brush, there is somebody over at the service center that will pick up one brush, put it in a box, charge you $20 of shipping, and they will ship you one brush, which does you absolutely no good because you need two brushes, and they are not car people. They're only picking parts. And if you ask them, they'll tell you we don't even bother to pay them to pick parts, but that's between them and whoever. You need two brushes. Again, if you hit 2 and your finger slips and you order 21, we will send you 21 brushes. Okay, so just be careful how you order your parts.
Did you ever carry those on your truck when you were out?
All the time.
How many would you say you carried in as far as like an inventory of them?
Or 21.
Are you a fucking smartass?
I only carry 2 because you don't replace brushes all that often. And then if you did replace 2 at once, whenever you were putting in your weekly order, because they don't weigh anything and they don't take up anything in the box, you would just order 2. Now you wouldn't want to order just 2 of them separate because they're just going to charge you a lot of shipping to get it to you. But if you're putting in an order like for damaged fingers on Auto 34s, just throw in a couple of motor brushes in the package. Won't weigh any heavier and it won't be any bigger, so you'll save on shipping. Especially him, he needs to save everything he can on shipping.
So what does the motor brushes do exactly?
They transfer the electricity down to the to your stator. So it's allowing you to a motor because it's allowing it to spin inside and still keep electrical connection.
And off topic, how does a brushless motor work?
Induction.
Yeah, you have north and
magnets.
south or north and north and south, and somehow they're able to physically turn the magnetic field left and right and left and right and left and right, and by doing that and doing that and doing that and doing that, it gets it going, and that's how you have a brushless motor. So, it's good for DC. It's not so good for AC, which is why most of your Milwaukee stuff or your lawnmower that you got, if it's a cordless like the Easy Go or whatever, it can be brushless motors. So since this one's up here and we're just talking about stuff, this connector right here is very fragile.
Bless you.
This connector should also be at a 90-degree angle from the Hall Effect sensor pickup board. Okay, this one over here. What happened to this one over here? This one over here. Someone straightened it out.
I did.
Someone had their way with this connector. This connector was laid down at about a 45-degree angle. Normally oh man, those things are bent.
Mm-hmm.
Those things are bent. See, because you can't put it all the way on. All right. You don't want it to look like this. You don't want a gap in your wiring harness. That means somebody before them has bent this. Usually what happens is this happens as you're putting the spindle back on the balancer. When you're putting the spindle back on the balancer, you have to have the spindle and you have to push the spindle all the way to the back, and you have to rotate the spindle up a little bit so you can plug in that connector. Being an engineering company, we give you a very gracious hole that's about 1.5 times bigger than the connector. Could we have made the hole bigger? Yes. But since we're an engineering company, we expect everyone to take as much time as we did to replace the spindle and make sure that the connector's in the hole and not either on this side of the hole or that side of the hole, and just jam the thing in there and then bolt it up. Because they don't actually work in the real world. They work in a lab where it's clean and doesn't smell like rat pee, and they don't have to worry about it. So to an engineer, that hole right there is about the size of the Grand Canyon, and they can't figure out why you can't put the connector in there without bending. Awesome. That's actually a fairly gracious hole. Right, because everyone always, engineers will always measure stuff before they powder coat it, because powder coating is an unknown certainty, because powder coating can be thicker or thinner in the same spots depending on how the guys use, how the automatic robot's using the brush. So they don't measure holes after powder coating. So if they measure a hole and then it gets heavy powder coating, that hole is not nearly as big as the hole was when they measured it. And they're going to be like, well, I don't understand. We made the hole this. But yeah, but then the powder coated it, and now it's only this instead of that. All of a sudden, you're breaking stuff because you're bending connectors. Okay. You're going to have to be very careful with this. All right. So the bearings that are in here, there is a preload on the bearings, as they've noticed, because when they took the clip out, it fell. Okay. If you put a screwdriver in here, you can very gently move. This is going to be bolted to the balancer, so the spindle itself is going to move. But if you want to notice, this thing moves just a little. You can see that thing move just a little bit. Okay. If you notice, I'm just using a finger and I am just moving this a little bit. Okay. If you get in here and you move that and you hear a pop, you just bought a spindle. Or the customer just bought a spindle, because you're burning in hell somewhere for not telling them you broke the spindle and you're just going to make the customer buy it. Okay? This is actually supposed to be here. This lets you know that your bearings still have that preload on it. Okay? If you're just balancing tires, we won't notice that preload is gone. But when you road force tires, because you're putting an outside pressure on the wheel, you're going to get all sorts of weird problems. Like you'll get centering error checks, you'll get chasing weight problems, or you're going to get really erratic actual road force numbers. Like one time you'll get like 6 pounds of road force, and then the next time you do the same tire, you'll get like 25 pounds of road force. It just depends on, because that's it's not centered anymore. The thing's just all flopping all around here.
Why would you even bother trying to see if there's play in that? If there's a possibility that you could break the motor or break the spindle, I'm sorry.
It's already broken.
Well, yeah, you're checking to see if it's already broken. That's all. So you're checking it to make sure that it's still good.
I just don't want to. I'm not trying to break the spindle.
Well, so go ahead, just you can feel it.
Isn't this play also so that the force transducer?
It looks like your spindle's broken. That'll be easy.
So you're not actually moving.
I know.
And it's easier. So there you go. You can see it move maybe a 1/16 of an inch. The other thing is you can actually feel it like push through it, and then you can feel it hit the stop. Okay. Yeah.
Is there just some kind of slippage inside with the spring?
It's not really slippage. I call it preload.
Oh.
I'm not sure how they managed to preload it, but they managed to preload it in a way that it gives a little bit of left, right.
And what?
I wish I knew how. Because again, I think I've seen the inside of those once, and that's because the model shop decided they were gonna like cut it in half. I don't have that cut away. I wish I had that cut away.
If you hear that popping, what is it?
You basically moved the bearings.
Oh.
And now the bearing is not here. Now the bearing is out here, and now there's no more preload left, and you have to replace the spindle. Number 2 Phillips. Somewhere. All right. So we're gonna take off the encoder board. So we have a wheel encoder on the. Steve's already over here. I thought Steve had put that one in there. Plus, this is a newer style. The encoder board looks just like the one on the on-car brake lathe or on the Revolution tire changer, right? So I have 2 of these, but right here together. This is my A channel and my B channel, and then the one way out here all by itself is my home pulse. Okay. If you look inside of here, you can see that it's there's brass. And let me see if I can rotate this around to get to where the home pulse is. Thank you. So, is that the home pulse right there?
Yeah, super.
There's the home pulse. All right. So if you notice, the home pulse is actually a fairly big.
Oh yeah.
Freaking do that to me. Okay. The home pulse is a fairly big notch in relationship to the rest of the actual wheel encoder. Okay. So it's almost the thickness of 2 whole entire windows. Right. So it's in comparison to you can see how little the little bitty windows is on this wheel encoder. That wheel encoder is brass, obviously, because we can't induce magnetism because we're shining lights and things are moving. So we don't want to. We always make it. The only time I've never seen one not made of brass is the one in the Revolution, where it's made of that really weird plastic material. All the rest of them we've always made out of brass. It has to do something with magnetism. I'm not sure why. Because we're not actually doing anything with magnets. But I guess because it's an encoder pickup. I don't know. Because we're basically shining a light, right? And the light either hits it or the light doesn't hit it. But I suppose magnetivity could mess with the optics a little bit. I don't know. We just always use brass.
Usually just encoders instead of sensitive feedback.
If you do notice in here on my right side or on the back side, there's a really crazy washer. It's not really a wave washer, but it's one of those funny. It's one of those funny. It almost looks like a honeycomb washer where it's got all the right angles, and then there's air gaps in it, and then it squishes itself together.
Like
It's kind of hard.
oil
to
ring
describe.
expander almost.
Like with the little nubby zone.
Where is it?
Yeah, I suppose.
Oh.
Someone put the light back in there for the camera, so you can see it on the back side. It's right there. You can see
Just
the.
washes it out.
You see it like that.
So we somehow too we can't hard mount it because it's made of brass and it'll warp or deflect. So we put the spring on there, and the spring on there keeps it from turning independently. but the spring doesn't put too much pressure on it, so we don't deflect the brass, because it's brass is very malleable. Big word for the day, malleable. So we don't want to deform the brass because we need to keep it running straight. We don't want to over tighten it, but we can't have it slip. So we just use spring pressure on it. Usually it keeps it in place. Okay. Everyone seemed to figure out the trick on the pulley. The pulleys are tapered, right? So after you took the bolt out, all you had to do was tap on the pulley, and the pulley will resonate at a different harmonic frequency than the spindle, and then the pulley just falls right off. Okay. These are also only put on. These are only put on. You know, you have your pinky out and you just barely tighten the bolt. In the field, you're going to want at least 2 ugga duggas out of your cordless impact gun to make sure that it stays on. It only needs to be 20 or 25 foot-pounds because again, it's a tapered fit. But at 25 foot-pounds, that tapered fit is on there for life. So normally, what I do is, you know, if you have an actual hammer or you're using your crescent wrench as a hammer. You literally just have to, so if this is on the motor, you're just going to like tap it and then tap it as you spin it. And then as you tap and you spin and you tap and you spin, again, this is vibrating, that's vibrating, and it will literally vibrate itself off of each other. Okay? You don't have to hit it. You can hit it like me. You don't have to hit it like you. Right? It's just a little tappy tap. Okay. It doesn't take a lot to tappy tap. You'd be surprised. Okay. That bolt was a 15/16 bolt. For those of you metric people, you probably grab for 24 millimeter and goes, hey, it's 24 millimeter. It's actually 15/16 because it's made here in the good old US of A. So, standard bolt. What else are we going to talk about? Micro switches. So we have what's called a saddle and a little micro switch. If you look up in the parts drawing, you can buy this micro switch independent of the saddle. However, we use the world's strongest glue to hold this micro switch in, and by the time you get the micro switch out, you have destroyed the saddle. So just keep one of these on the truck. This is the old design. This is the old taper. The newer taper is shorter and more pronounced. You cannot use an old hose in a new saddle, and you cannot use an old saddle on a new hose. So if you when you take the hose off, look at your tapers and figure out if they're the same or not. If they're not, it won't push on the little switch. Okay. I am 95% positive, just like everything else we do, we use the 2 outer pins for the switch, not the middle one and the top. We use the top and the bottom. It should be a normally open switch, and then we close it. Normally closed and then we open it. Doesn't matter. It goes from one state to the other. Okay. However, the state matters. I just can't say what the state is. Okay. I know on a Revolution tire changer, it goes from a 0 to a 1. When the hose is back home, number 46 on that chart says something about inflation holster. And 1 usually means that it's on and 0 means it's off. So 0 is open when it's closed. We'll go with that. Okay. So we're going to say that this is a normally open, and when you slide this in, it actually closes it and makes the cotton move. Okay. You can hear it. Carry a whole saddle with you. Okay.
And a hose.
And at least a hose.
I have one question. I hear you say that. I've heard you say a number of times that Honda is an engineering company, right? Oh, is there a difference between Honda, the other guys who make tire equipment? Make tire equipment. So, because I've heard you say that Honda is an engineering company. Huh? But then there are other manufacturers that make tires.
Well, we are also a manufacturing company. So we manufacture what we engineer. So we're an engineering company first because we have to come up with our own design and our own concepts. And then once we get a concept, there's a secret development lab across the street. We develop it to get it to user acceptance testing. We go through alpha testing, beta testing, and then after we do once we get to all that, once we prove to ourselves that it's a workable design, then we'll actually put it into mass production and the plants down in Mississippi will then produce what we normally will have 4, 5, 6 years of R&D in something before we actually bring it to market. So, we probably right now across the street we have somewhere between 40 and 60 engineers, and they're just like they're NASA, like Armageddon, they're just sitting around thinking stuff up. And then we have a backup team thinking of stuff that they didn't think of. And then we have a third team that has to fix everything that the first 2 teams thought of, but it didn't work right. So then we have the product improvement team to make sure that, so we're engineering company first, production company second.
I'm sorry, what is, which car manufacturer is an engineering company that do not like to be called a car manufacturer?
Porsche.
Bro,
I have no idea.
Honda.
They don't
So,
want to be called a
I
car company?
I actually learned that
They're in so many different
from
industries,
Nissan. I learned it from Nissan ex-CEO who they lock up and throw in jail and so on. He said that Honda was not a lot. Honda is actually an engineering company.
They are actually, they have a lot of.
And now they're actually,
I used to go to
they're
the
actually
North Carolina
changing
plant.
to an innovation company.
Well, because they make generators,
Yeah.
they make side by sides.
Well,
Make,
yeah,
What about
look-
Mitsubishi?
I was gonna say, look at Yamaha.
yeah,
Yamaha
yeah,
makes
yeah.
wave runners,
Pianos,
trumpets, pianos.
guitars.
It's one of the
Sorry.
first site in North
Yeah.
Carolina. They do have a huge engineering plant.
So
Also,
Honda doesn't like to be called a car
They're
company.
building around
They
here.
are engineering company.
Did you hear
You
that from him
disrespect them if you call
before or after he got snuck out in the suitcase?
So I guess every car that they make, right, was really heavily engineered for perfection rather than designed for perfection.
Okay.
Pininfarina is a design company.
Right.
But Honda, they don't like to be called a design company.
They don't really design; they just make cars
They
that
designed
work.
that Prologue, it's not doing too well.
Say
Just make cars that work, you know.
Not doing too well.
It did.
Electric
Whose
cars.
is this?
This is us.
This is you?
Yeah.
Great. I don't like people who cheat.
They've already hit the ground, so.
Have they? You put them in already? So early models here, the 9702 and the 9712. The spindle itself is tapped for the bolts, so you don't have to worry about where you put the spindle. Okay, everything past
Exactly
there
what we were talking
that
about.
has this really interesting, weird, I don't know what you want to call it, housing. Okay. Yeah, it's like track housing or something like that. Pocket screwdriver.
You need a little one? Flavor.
So, pocket screwdriver.
I used this the other day.
When you're putting these back in, the spindle cannot touch the vibration structure right here. Okay. What happens right here at the end of the screwdriver? There's a weldment. If you put the spindle all the way touching the vibration structure, the back of the spindle rides up on that weldment, and then your spindle is no longer horizontal. Your spindle is actually pointing down a little bit, okay? So the trick with the pocket screwdriver is you take the pocket screwdriver right here to where it goes from flat to nearly round, and you put the pocket screwdriver right here between the vibration structure and the back of the spindle. Okay, and if you have that much of a gap between the actual spindle and the vibration structure, you have forced the spindle out far enough that the spindle misses that weldment, and then the spindle is actually horizontal and not tilted down. Okay. The other way you'll know that you have the spindle incorrectly, I don't know if it was true when you guys took these off, but the belt should track in the middle of the pulley. If the belt is too far one way or too far the other way, you know that you have your spindle either too far out or too far in. I'm not really worried about too far out. I'm worried a lot about too far in because, again, of the weldment. I had a self-induced mistake that cost me about 4 hours of my life because I was arguing with the guy at the lab that there's no way I had it too close and he was an idiot. And I finally looked at him. So, one of those mistakes that stay with you. Usually, all my stories are my mistakes. That's how you have to learn to. So, the only thing is, if you go too far out, then the belt will start to fall off the pulley. But as long as the belt has a little bit of pulley on either side of it, you should be okay.
Mm-hmm.
The other thing that I always found interesting that I have never had anyone explain to me is we use a V-groove multi-ribbed belt on a completely smooth pulley. To me, the pulley should be grooved to accept the 10-rib multi-rib belt. It's been smooth since Mike Douglas made the first one, and that DSP 9000. We have never had a grooved pulley. Okay?
BMW does the same thing, drives me crazy.
We did manage to do something stupid for a while, and we would drill here because we had to make sure that this was balanced. So we drilled holes in here, which then just ate up the belt. So then we actually started to move the holes that we drilled. This one doesn't actually have any. How about that? A lot of our pulleys will have holes in the side of them because we're trying to get it balanced out. Does that one have? That one has it. Okay. So we actually put these on its own little fixture, and we have to make sure that that thing's not inducing any vibration, right? So somebody was, I don't know if they had a liquid lunch that day or what, but somebody went a little heavy on the drilling. Looks like they counter drilled a little bit, but fortunately for us, we got it to balance out. I don't know. It looks like that one took a minute or two longer than the rest of them did. They drilled it on the inside. Yeah.
It doesn't even look like casting issue or something. Doesn't even look circular.
No, that does look like a casting issue. It looks like it's hollow. So this one doesn't have any marks either. So some of them have marks, some of them don't. Yeah. Like that one there evidently was really bad and we had to fix it. Let's talk about
I wonder if they take it out whenever they machine it instead of drilling it out.
Is that a second microphone?
It is. I was gonna hand it to somebody if they wanted to ask a question, because in your videos you can't hear what anybody is saying. But I don't really have a good solution to stick this thing on something.
We're gonna go with this one, and we're gonna go with this one. This is actually pretty cool. So I have two. This is a 4513. This is a 4513. Oh wait. Oh, it is. Oh, this is cool. Okay. This is okay. So let's do it this way. The part number starts. Both of these part numbers start with 45. 45 means it's a circuit board. The 1379 is the actual part number of the board. This one only has a -1, right? A -1 means we made it. This one has a -1-2. And if you notice, there's a ginormous difference between a -1 and a -1-2. Okay, this is your air pressure sensor. That tells you how much air pressure is in the tire. And if you notice, it's hard mounted to the circuit board. It's soldered to the circuit board. And when this air pressure transducer would go bad, because I would say the word, and now this transducer is bad because I said the word too close to it, you would have to replace the whole entire DAQ board. And our customers were started, I don't know how, but some of our customers were getting really upset that they had to buy a really big board for a really small. So what we finally did is, if you notice, we still have the holes and the pads for where the pressure reducer, because it costs money to redesign it. So rather than redesigning it, we left the design alone. We just told the computer not to put that part on there. And so now, rather than having a surface-mounted air pressure transducer, we have a remote-mounted transducer. Now we just have an extra connector somewhere so that it can connect to the board. So
It still gets the data.
it still gets the data, it just gets it differently. So be careful. Sometimes, it's like, well, that's the same part number. Technically it is, but technically it isn't. That second dash is very different, okay? The other thing we're doing here, this one here, if you notice, this one here has a big pile of jism on it, okay? That's keeping out the humidity from something that's really sensitive, okay? This has to be circuit board grade quality Silicone. Because if you just get regular tile and bath silicone, it has a pH level. It's actually slightly acidic, and it'll actually burn through the board. So we always have to either have a base or a pH neutral, and then it should be on the other side too, right? So it's actually not on this board. There's just a little bit on there, but this board here, someone put it on nice, right? It's nice and heavy. Okay. We had trouble where the humidity was getting between the IC chip and the board and shorting it out. Now that doesn't cause the board to go bad, it just causes the board to short out. So if you had your wife's hair dryer, you could turn the unit off, blow in nice warm air, get the humidity out of it, and then the thing would boot up and work just fine until the next time it rained. Even if this thing was on, it creates enough heat to keep it out of it. It's when you turn your balancer off at night and then it rains at night and it's like 95 degrees at 95% humidity. We don't have that here. So it took years to convince the people here that that was happening. I guarantee you it was happening. Happens a lot. So they finally acquiesced and started putting on the electronics.
Is that all that shiny?
Mm-hmm. That's just it's just a different. It's just not as thick.
So can you, if you diagnose one to have moisture, you hit it with a heat gun. Can you just add that?
You can.
And then that.
But my problem is, as soon as you take the heat gun away, you're trapping in whatever humidity's in the air. I don't want to trap 80% humidity in the air, right? Where they make these boards in Mississippi, it's air. It's a controlled room, right? I'd rather trap 4% humidity in the air. So, as much I dry it out and let the guy continue to use it. You don't have to worry about that anymore. We seem to have that really locked down. Sometimes boards won't have this anymore because we actually redesigned the board for so that the humidity can't get between the chip and the board. But a while there, we were having we were having troubles with the board. So the good news is they put it on. Okay. This is an actual replaceable IC chip. You can't do that anymore. All of your chips are going to be hard mounted and hardwired. At some point, they decided they needed to change the firmware, but this board is ancient in circuitry terms. Okay. The other thing, this one here is nice because it's all surface mounted components. The other thing, at some point we decided to save a half a penny a piece, and we no longer give you the little guy standing up. Now we just give you pads. So you have to take your if you're going to be one of those voltmeter guys, you have to put the voltmeter on an actual square pad because you can't put the alligator clips on here, which is terrible because if it slips between two pads, you now have become a welder, and those two pads are now not air gapped. Like I said, we're probably saving a half a penny a piece on a little, whatever you want to call these, test points, probes, terminals. Now everything is just a flat terminal. Okay. Since he's here, and I haven't told you guys this yet, I'm going to blow your ever-loving minds. Every time you see a set of solders, one solder is always square, and the rest of them are round. The square solder is terminal number 1. And we have done that on every circuit board we have made since the 70s. Okay? Once you see it, it'll blow your mind that because we're wicking that solder, right? We're floating this thing this way on a river of solder. The solder has to wick its way up into the board. So the board is actually cut out either in circles or squares so that when the solder wicks up into it, it fills it out and it gives you a square. It is crazy.
Oh, there it is.
That's why I sent ours over there.
That's wild.
There's a square. Yeah, so each set of
No
those
way.
pins has its own number 1.
That one's the square one.
I actually found that out by accident one time. A guy asked me to
What?
check
No
pins
way.
2 and 3
No
on a
way.
rack.
Fuck's sake.
How much? Yeah, and he goes, "Oh, pin number 1's the square one." And I'm like,
That's actually
You
really
mean to tell
how
me
did I
for
never
40
know that,
years?
right?
Engineering company.
Yeah, we're an engineering company.
That's the difference between them and
Yeah.
So each socket, that would be 1, 2, 3, 1, 2, 3.
That's cool.
But yeah, that's really handy to know because someone may ask
Yep.
you one day,
Lower left.
check between 4 and
Fucking
5.
wild.
Oh, it's even on there, right?
Yeah, I mean,
Little
oh,
circuit boards, big
Jesus.
circuit boards. We're gonna have a square pad, right?
That's
At
pretty
this
good
point
to
here,
know.
you just want to go home and be like, man, that's
How many other people do
Square
that?
holes.
It kind of makes me want
Not GM, I can tell you that.
No, Ford doesn't do it either.
The other thing, I think that one's only like a 2-layer board. We make up to 4-layer boards. We don't do 7s, but we do 4s.
Could that be a signature on the
I think it's honestly just to help whoever's trying to measure the voltage to know where pin 1 is. Right? Because most people don't put it on the solder. Most people will put it on the wiring, right? Wire number 1 will be this color, or wire number 1 will have a stripe. Right, because like on Panduit stuff. Let me have that. No, wait, I can do it on this one. Where's that blue one again? Right. So on this blue one here, we have a Panduit connector, and on the Panduit connector, you got the 1 red stripe. That's pin number 1 on the wiring harness. Right. So sometimes I have, sometimes because I don't make that blue board, right? So I don't know where pin number 1 is on the board, so I have to make the wiring harness show me where pin number 1 is. That board's made in like it actually literally says Szechuan China on the board. If you turn it over.
I love this.
That's just Texas Instruments?
Yeah.
Yeah, yeah.
Right there in Sugar Land.
Okay. Yeah, in Texas.
Yeah.
It's Texas Instruments. Texas Instruments. It's just not named Texas Instruments for nothing.
And you can look at the bottom of this board.
Yeah, it doesn't have.
No.
I think this is yours, right?
So what you're saying is that
That's,
that board is somewhere between
Yeah, I don't know.
TI-84
Yeah, okay.
and
I'm trying to keep it because I don't want you guys to put together. Okay.
TI-87. You know what TI? Do you know what it's?
Yeah, so the
Okay,
like this.
looks to me
So this is called a Panduit connector. I don't know why pandas in zoos are important, but we call it a Panduit connector. It's just the name of the connector. It's just flat. You put the wire in, you scrimp it down, and it's got like the shark bite fittings to where it just pierces the wire, so you don't have to strip everything out. Where's the? Let me have that DC drive. Not the DC drive. You gave me exactly what I was looking for, and that's not right. No, it's fine. So, put it in here. Is that going to fit? That fits. If I turn it around. Okay, this DAQ board is made correctly to where the
connector on the ribbon
the actual bump out, right? It doesn't allow you.
doesn't allow you to go backwards.
It doesn't allow you to put it in backwards, okay? This one here you have to put in one direction, just like the boy band, push down, and that pops it on. That DAQ board and that balancer, every single class will put that ribbon in backwards because the DAQ board and that balancer allows you to put this in 2 different directions. I'm not sure. It has to be some type of oversight because when you put this ribbon cable in backwards on the DAQ board and the DC drive board talk to each other. And I believe on the DC drive board, does Era 6 say something about a watchdog? It's a really weird term.
Yeah, weird.
It says watchdog. None of it doesn't say watchdog on any of the numbers?
It says watchdog something.
Oh, yeah. Oh yeah, Watchdog Dropout 6.
6, okay. So what happens is this board talks to that board, and we have to establish communication. If this board gets all the way booted up, this board won't actually blink anything. When this board boots all the way up and the conditions are met, this board will turn on the 2 relays to put power to that board. If that board gets power, it looks for a signal wire. And if you don't have this hooked up, or you have it hooked up backwards, or for some reason this thing stopped communicating with that thing, you're going to get I don't know. I guess it's like the Watchman. Is that DC or Mark?
DC.
DC, okay. it's like the watchman, right? So we're looking out for each other. If it doesn't see the watchdog light, it'll blink an error code 6 to let you know that it doesn't know what it's doing. Right? So it's smart enough to know that it's not smart. Right? And something's not. Because the DC drive,
They weren't in.
is there. The DC drive doesn't make decisions for itself. The software tells the DAQ board to make the decision on when to put power going out of that to turn the motor either this way or this way, depending on which way it needs to go. But the DC, that's why it needs the ribbon cable, because the ribbon cable is the communication between the two. And if it doesn't have any communication, then it pops up the error. So, okay, that's yours.
Oh, that's why you know.
It's a wake up signal from a master.
Yeah, that's why it's dumb.
But no, it was
Yeah.
right when you're up here, so I put it back in.
A liquid switch. Yeah. On the cabulator.
Your board.
So
That's
it's
definitely not your board.
Communication.
This one might be your board.
This was your guys'. That's
No.
ours.
We only had one.
That's ours.
Okay, that's yours. Okay.
Well, there it
Um,
is. So did I.
So older DAQ boards had more keys. Newer DAQ boards only have one key. If you notice, it only has one key holder. This is why sometimes you can't put older software in the newer balancer. Older software needs to see more keys. If I put 4.1 in here, it won't work. If I put 6.2 in there, it won't work, because 6.2 is only looking for one key and that has 4. That one's looking for 4 keys and only has 1. There's multiple other reasons why that happens. If you have one of these boards with this little loopy dealy, the loopy dealy is because we went away from those magnetic reed switches to Hall effect sensor. But I still have the pin out here, so I basically have to like short the pins together, right? Because if it sees that the reed switch is open, even though I'm opening and closing the hood, it won't let the balancer spin. So I have to trick the machine into thinking that the hood is down, and then the actual Hall effect sensor plugs into a different part, and then it gives me my actual angle on what I'm doing. Okay, so it looks innocuous. It looks silly, but it's there for a very gigantic reason. Okay. Since this is just a single wire, it's a 37 because it's not a cable, which is a 38. And there's the part number on it. The other thing it tells me on the other reverse side is there are 2 different sets of numbers. One is the operator, and then I think the other one's the shift. So I can actually figure out, like if this was made wrong, they could figure out who made this harness. Okay? And we do that for all our wiring harnesses. So sometimes the lab will ask you to read off the numbers on the back, and then the people in Mississippi will go in and figure it out. One's an employee number. I know one's an employee number.
So they just
The
know
other
who
ones I
to,
think is
they know who
the
to yell
Yeah,
at.
they walk around with one of those sticks.
Yeah, they walk around with a stick. If you notice though, these pads here, they don't actually ground anything, but yet we put a screw in it, and we make these. Yeah, but we make the pads look like they ground, right? They look like they ground, but yet when you, unless of course it's in between the 2 layers of the circuit board that I can't see the trace where it grounds. Because sometimes they'll ask you to go ahead and they'll ask you to float the DAQ board, which means it has to ground somewhere, right? Because if you're having weird electrical problems or weird balancer problems, they'll say, hey, just float the DAQ board for me, which means just pull it off of the heart and just let it sit there in air and see if it gives you the same error. And then we can try to figure out if there's something wrong going on in the board. Okay? Stuff, lots of stuff, pokey stuff. The old Molex connector. This is the old way, the 4-pin connector, a yellow, 2 blacks, and a red. And then we decided that the Molex connector was taking up too much room on the board, or the Molex connector cost us 3 cents instead of 2 cents. So then we went to the little black connector there, like on that board there. And that is, I don't know, maybe that's more of an industry standard. It's just a little 4-pin connector rather than this giant, because you have to have the big giant pins too, right? So the pins cost more money, the connector costs more money, but that's more of an industry standard size pin.
Still made by Molex.
That's still, and when we were putting together that balancer on Monday, that's the only connector that is that shape. So you can't mess it up when you're putting it together.
Well, someone tried to plug it in 90 degrees this way, and they were going to be they were pouring the coals of that thing. They were going to get it plugged up.
But I mean, obviously, you can't plug it into any of these
No,
other
correct.
ones. Is what I
This
meant.
It is a square.
Yeah, it's a square.
The other thing that I noticed, every one of these has a really long white connector. That is your spindle encoder cable. Your spindle encoder cable has been this since the very first balancer, so we have to keep this connector so that you guys can use it on anything that you want to use it on. Okay. What else are we talking about? Oh wait, this is
When did they? I don't get that.
no, but isn't there? Oh, you know what?
You
watching this?
Oh no, it's right there. That one's a little longer. That one's a little shorter. You still do that.
Yes, when did they start putting keys on the back of the monitor instead of on the, or is there any correlation?
No. So
That's fine.
technically, there's like a keys board in there.
Yeah, it's on the back.
But that's its only function is to be a keys board, right?
Yeah, because if you look on the back there,
It's got some USBs, keys, and then
Yeah.
a couple of good sized wires going through it, but nothing.
Yeah, but that's the only thing it does is it houses the keys.
Yeah.
So we were able to get rid of a whole entire circuit board and just put the keys on the DAQ board. Right?
yeah, because when we were looking at the Road Force Elite, I was like, "Where's your green board up there with your keys?" And he said, "Well, ours is on the DAQ board."
So the other thing we used to do is the word Hunter Engineering on the arm underneath the monitor. That used to have its own board, and all it was white LEDs because we lit up the word Hunter Engineering. Because having the word Hunter Engineering wasn't good enough; it needed to be backlit for maximum efficiency.
That way everybody knew that you were using Hunter equipment.
So
That's why we lost the connector.
that's why we lost the connect. Yeah, we had to pay for the light. Yes, yes.
It's funny to watch the balance of the back and forth.
We're gonna finish out strong. We're gonna go eat a buffet, and then when we get back, you guys are gonna put these all back together again. I'm getting a pokey stick because when I put my hand inside the balancer, no one can see anything as I have a big sausage meaty hand. So I'm gonna try to make this work a little better by having. So we're gonna deal with this one because this is the newest, the latest, greatest one. Hey, look!
Hello there, bro. You happy to see me?
I wondered where those got off to. Look at that!
Oh, those are nice.
Look at that! Holy
get some
cow.
memory players.
Yeah. Put those in the bottom of the red, because the black toolbox stays in here. The red toolbox goes next door. The red toolbox goes to tire changer.
So you want to
In the red one. Yeah, because it should go all the way in the bottom drawer.
I was really hoping that was a box of nitpicks.
Oh, I know, right? It's almost as good, but not quite.
Just making it sting even more.
Joshua is taking the Steve route for putting.
Well, I was just trying to get the lid to close. So I don't care about it. All right, we're just gonna go to the drawer.
Hey, I appreciate that. All right.
Yeah, don't put it in that one then.
How about that red one?
Put it. Does the black one have room in the bottom drawer? As long as it's somewhere in the bottom drawer, because they go in a bottom drawer somewhere. Otherwise, it doesn't have a low point.
It's not fitting in this one either.
There's a thread chaser in the bottom drawer of the black one.
Yeah. Leave it out and we'll figure it out later. But don't leave it down here because it'll be gone for another 8 weeks until I can get it to where it needs to go. All right. Oh, it's a low point or a heavy point. Either way. All right. We're going to start in the. You guys are going to have to get uncomfortably close. Up front here. Up front here at the bottom of my dowel rod is all of my air components, okay? This little guy on the side, this very little solenoid on the side, this is my auto hood solenoid. So this solenoid doesn't exist everywhere in the universe, but it exists on this Earth. What is it, 636? Aren't we Earth 636? Marvel?
636.
636?
616.
616 or 616, not 636. Okay. Anyway, on Earth 616, where you happen to be standing in the multiverse, this little solenoid right here causes the auto hood to go up. Obviously, you still have to lower it, so all we have to do is put air in the cylinder to raise it. Okay. Now, all of these air solenoids right here look familiar. That's because they're the exact same air solenoids in the Revolution tire changer. It's the same block. It's the same everything. They have the same little blue button on them so that you can manually cause them to work. Okay. If you notice this little green board right up here, this little green board and this little holder is the exact same out of the Revolution tire changer. It's just it gets sandwiched between the air solenoids and the actual back part of the balancer. Okay. So pressure transducer, right? Same pressure transducer that's in the Revolution tire changer. Okay. All right.
It's just not screwed on anymore. It's held with a zip tie.
Well, yeah. Evidently, blue zip ties are equal to
Loctite.
it's like blue Loctite. Yeah. All right. This guy here is the vibration structure. Okay. If you notice, it's notched out. It's welded to here. It's welded up front. It's got a weldment here, but only this little part of it's actually touching the vibration structure. And then back here, I've got a little bit, but if you notice again, it's notched out. Okay. This is what allows the tire to shimmy and shake the vibration structure so that my force transducers can pick up the imbalance and can work together to give you the numbers on the screen.
Give you the wobblement number.
To give you the wobblement number, yes. It's the wobbleometer. Ooh, wobbleometer. I like a wobbleometer. This guy right here is called a load cell. Most people know load cells when you go to the trash dump and they weigh you going in and they weigh you going out. This particular load cell, however, works in both directions. If you notice, it looks like a Z. So what we're doing on this Z is we're pushing on the legs of the Z. If we push the legs together, the counts are going, I don't know, up or down. And then when we're pulling the legs of the Z away, the counts are either going up or down accordingly. And that's what's giving me my lateral force number when I'm trying to measure a tire pull. Depending on which way the tire pulls, the legs of this pressure transducer, pressure load cell. But it depends if my load cell is getting compressed or contracted. I can tell which way the tire's trying to pull. Okay. But that's what my load cell is doing.
The orientation of that, is it always lay flat?
No, sometimes it's straight up and down.
Okay, that's what ours was. When we cracked it open, it was
straight up and down. I don't really think it matters because it's just measuring this way. Sticky fingers, sticky boogers. All right, it's just measuring this. So it doesn't really matter which way it's oriented. Okay. Micro switch over here. Really super high-tech micro switch. So when you step down on the pedal, right, it knows that you step down on the pedal because the micro switch closes and it sends an electrical signal to the DAQ board that I'm actually pushing on the pedal. If you want to look at that one, it's nearly the same. This big black gigantic learned something about Jake today. All right.
That wasn't me.
That was Josh. That was Josh.
I thought that was a screwdriver in your pocket.
I can't believe this. I can't believe this. Who's speaking on my behalf?
Right.
That's a screwdriver in your pocket.
You did not deny it.
This is so unfortunately in the parts diagram, this is called a high clamp brake. We will never ever in front of our customers refer to this thing as a brake. This is called a spindle lock or a spindle clamp. You step on it to lock the spindle in place while you're putting the wheel weights on so that the wheel doesn't auto servo or move, so that you don't put the wheel weights in the right spot. It does have a pad. The pad is held on with Gorilla Glue. If you tell people it's a brake, the balancer stops the tire by, so all right, the DC drive has the ability to pulse width modulate voltage, right? So 0%, I don't have voltage on either side of it. 50% means I'm deadheading against each other where I'm holding it so you can put the wheel weights on. If I go 70-30, it's going to spin this way really fast. If I go 70-30, it's going to spin this way real fast. Okay, so the balancer basically stops itself by putting voltage against how it's turning. And that's why we need the braking resistor, because the voltage has to go somewhere. So it goes through the resistor, and that's how we slow the tire down. Okay? It takes 3 to 4 seconds to slow the tire down. You guys work with that one guy where 4 seconds, he could have had lunch and driven home by then. So he's gonna, it's like I know where you guys work. He's gonna use this guy as a brake. The problem is the Gorilla Glue heats up, and then the brake gets shoved down because it's spinning this way. There's not enough clearance between the pulley and the vibration structure, so this brake pad gets firmly wedged in between the pulley and the thing, and then the belt doesn't have enough oomph to spin it in either direction. So then all you have to do is come out here, pop the hood off, spin it in the opposite direction. It'll spit the brake pad out, and then you have to, I always replace the whole entire clamping on, right? I don't carry around Gorilla Glue, right? It's, you can charge for stupid, right? So they get a whole entire bracket with a brand new brake pad on it. Most of the time, these brake pads are going to be worn kind of concave anyway.
That one's worn pretty good.
That one's been used in engineering testing. That was a test mule for engineering, which is why it looks.
Actually, that pad's like, I thought it was. It felt like metal. It was so worn.
Yeah, that one's really worn. Okay. So that's why we don't ever call this a brake. We call it a spindle lock. All right. People are gonna do dumb things with it if you do dumb things with it. Okay. All right. Force transducers. I'm gonna have to get the force transducers, but I'll have to hurry. I'll do my best. This is basically just an electronic distribution block. This is where power comes in, power goes out. It's all just full of 220 volts just waiting out to reach it. So don't touch it. All right. Way over here in the corner is my braking resistor. That's fantastic. This over here is my power switch. If you notice, this one actually has 2 legs going to it. Sometimes, again, we cheat and we only break one leg of power going to the motor, because if you break one power on 220, it's still not going to work. This one here is actually a dual pole, dual throw. Some of our switches are dual pole, single throw. But every once in a while, about once every 10 years, you'll feel the switch won't feel right because the throw is getting real charred, and every once in a while you'll have to actually replace the on-off switch because someone's actually using it, and it'll actually internally break down. Okay, doesn't happen all that often. I have relays right here. I have 2 relays. Okay, there's the urban legend is there's a condition on the 3rd gen balancer, the pogo stick there. It looks like someone the thing's on a pogo stick. There's a condition that somehow the DAQ board can falsify that the hood is down, and it will try to spin the tire at 300 RPM while it's booting up, which is obviously bad. So from the 3rd gen after the 3rd gen, we have these 2 relays in here. And what happens is the program has to boot all the way up. The software has to talk to the DAQ board to make sure that certain parameters are met. So like the hood is up, no one's double tapping the pedal. And then what happens is just like a relay, the DAQ board sends a small voltage signal to tell the relay to turn on or the relay to close. And then when the relay closes, a large voltage goes through the other side of the relay. So that way we don't come into the unfortunate circumstance where we're spinning this thing at 300 RPM while someone's taking a joyride that they weren't really ready to take. Now, it's 220 volts. Guess what's really expensive in 220 volts? Relays. What's really cheap? 110s. So we use two 110 relays rather than one 220 relay because it's cheaper. And we like saving money. And we're an engineering company. So you have two legs, two relays. It still works, but why spend money where you don't have to? Okay?
Mm-hmm.
That's what the two relays are for. The relays are what actually sends the power from my distribution block to my two. And again, if you notice, it's European. It's blue and brown, right? So I have a blue and brown. That's my 220. My 220 doesn't get turned on to that DA to the drive board until the DAQ board gives like the all clear signal. Okay.
It's like a safety circuit.
It's like a safety circuit. Okay. All right. Force transducers. How much time do I have?
10 minutes.
10 minutes. I can do that in 10 minutes. Then you guys can put them back together. Force transducers. Did you take one out over here? You did. Let me have. Is yours a double or a single? This is a double wire.
Yes.
All right. In that first one there, find me a force transducer that only has one wire coming out of it instead of two. So it's probably an impossible task for you because you don't even know what you're looking for. Yeah, that one. But see how that has two wires coming out of it? You're going to find one or two that only have one wire coming out of it.
This thing has been hot glued.
I'll take that one. That one's actually not what you're looking for, but I'll take it. So I need one more because this still has two wires coming out. So it's gonna look like everything in your left hand. It just has one wire. Minutes. So we're gonna go through this. You guys are gonna listen to this twice tonight since I'm gonna talk a little faster. I don't want to break that board. I don't know where that board goes, but I don't want it right there. All right.
He said that's an older one because it has the pressure sensor on it, so more than likely.
Yeah, it probably goes to the road force touch. Okay, let me have the other two that you had.
This one? You want this one?
That's okay, I'll use his. Perfect. All right, that's perfect. I'll take this. I'll take that. All right, so 1.5 billion years ago, when the dinosaurs roamed the earth after the Big Bang, we used this type of transducer. So this transducer was used in Gen 1 and Gen 2s and Gen 3s. Okay. If it doesn't have a touch screen, it's going to use an old-timey force transducer. This force transducer is basically just a point load, right? So we took these two things here. It's going to be held in with ceramic ball bearings, because those of you who don't know, ceramic is like impossible to break nearly. That's why they use them on brake rotors and stuff like that. So you're going to have two ceramic ball bearings in here, and the pre-adjustment is you just don't want it all floppy-loppy. Okay, so what happens is, as the vibration structure moves left and right, we can only measure in one direction. We can't really measure out, but we can measure how much it's squeezing in, and that's how we get, hemming and hawing and Elvis booty shaking, and we can figure out what number to give you guys, okay? So these are really old, okay? Yellow, green, and then this one here, I have two yellow greens. Force transducers are always yellow, green, yellow, blue. One is left, one is right, and I forget which is which. That's fine, it's on the sticker. But this is a super old-timey force transducer, okay? When we get back from lunch, I will have to explain ECAL because I have a really cool animated video, and it takes a minute for me to explain it. So I don't want to do that right now. I want to get through the hard parts, okay? So for those of you guys who love to know what's underneath here, because again, you are under no circumstances should you touch either of these nuts. These nuts. Don't touch these nuts. Okay. What happens? These nuts are preloaded. Okay. The preload. This is what's between the nuts. Okay. There's test points, and then more importantly, just like on the Revolution tire changer, there are two piezos, and believe it or not, the electrical inputs actually pick up the piezos, and because piezos, when they move back and forth, they create their own voltage. So these pickup wires here are actually picking up what the piezos are putting down. I think I can work that into something. So It's tough being a teacher. That's why we have to keep the preload correct. Because once you mess the preload up, my piezo's won't give out the right voltage. And the dudes over there in 0 and 1 land know that if it's set at the right preload, this is what my ranges are. So if I change the preload, I change the range. If I change the range, then I change the number. And then it's just nothing works right. Okay. So that's what's actually sitting inside of here. Okay. If I have 2 wires coming out, the 2 wires coming out, one wire does just sensing and the other wire does my piezos. Okay. If you're gonna have one, so if you notice, so this is in a SmartWeight Pro. This is in a SmartWeight Elite, a Road Force Elite, a Road Force Walkaway, a Heavy Duty Elite. Okay, this one's in a SmartWeight Pro. I have to make them the same because it's easier for the people in Mississippi to make the same thing. If you looked inside of here, it's still going to have all of that. We just don't hook it up because we have to save money. It's a $4,000 tire balancer. It's an $18,000 tire. I can't give you the same. So it's a pain point for you salespeople. It's a pain point. Can you deal without ECAL? And I'll explain ECAL when we get back from lunch. ECAL has to do with the piezos. Okay. So I can still figure out the shimmy and the shake. I just don't do the ECAL. That's the difference between a 2-wire and a 1-wire. Difference between a 2-hump camel and 1-hump camel? $1,500. So.
So, question: you keep saying 1-wire and 2-wire. You mean 1 lead and 2 lead?
Yes.
Okay.
So yeah, technically.
You're right.
You want to get
I'm just
1 lead, 2 leads. It does all go back into one connector, but this one does have 2 leads in this one. Okay. If you notice also, this one doesn't get grounded out because we're not doing anything with the piezos. This one has a little ground guy here, and you have to make sure that the little ground guy gets hooked up to a little 3/16 Allen wrench because I have to ground this guy out, right, for static electricity and stuff like that. Again, we make them the same so that the vibration structure holes are the same, so the CNC dudes are the same, so we make as many people as happy in production as we possibly can while just not hooking it up electrically, and then it's basically the same. Okay? I will get into ECAL after lunch. All right. This one. This is the bad part. Heavy duty elites. The heavy duty elite tire changer started out with these. Okay. What we realized is by the time you put a 350-pound tire on it, it takes this and it uses this as a lever and it twists it to the side a little bit. So now my piezos aren't getting uniformly squished. They're getting squished more on a point rather than an up and a down. So at some point in year 1 of heavy duty elitage, this is how awesomely smart we are. We are so smart, we're lazy. All we did was we cut the lever in half. So now it's only a half a lever because this is where my piezos are, right? So I still have to have a long shaft, but I can't have the deflection of it. So by putting it in the middle, it only deflects half as much, and I'm happy.
Less torque.
Less torque. Less torque. More torque. Less torque. More torque. All right.
I love that last name.
That's not a great day today. All right. So the problem is these two are not interchangeable. The vibration structures are obviously welded into the heavy duty elite. They are not interchangeable. We are terrible at record keeping, and we don't exactly know when we changed from this one to this one. So you basically have to take the top of the balancer off and go, oh, I got one of those. You'd have thought somebody somewhere would have made a note. A bulletin would have been great. Okay, so because even though the holes are the same, the way this mounts versus the way this mounts, that end of the vibration structure is very different. Okay, so you do have to keep. You can keep one of these, but you have to keep one of these because again, I cannot tell you when we change. Okay, it's not so. For my friend here from out of town, it's not that this is inaccurate. It's just that this is more accurate.
It's more data.
And I am probably talking somewhere in the tenths of an ounce range to the hundredths of an ounce range. I'm not talking whole entire ounces. I'm talking about tenths of ounces on a tire that weighs 300 pounds. Again, I don't know if the customer would ever feel it, but it didn't seem to pass the vibe check with us.
Trademark check.
So we decided we were going to make it better so that over the longevity of the balancer, you got as precise of a balance as you could get. But yeah, we basically just took that and we made a half a lever instead of a whole lever. And then we straight. Ooh, chicken dance. You gotta be Polish to do. You gotta be Polish to do a good chicken dance.
Don't take that one.
Don't take that one. Oh, that one's yours. Okay. How many more minutes do I have? 5-3?
None.
None.
12:01.
When we get back, there is a torque sequence to put these in, which is really important. So we'll talk about the torque sequence. We will talk about eCal. After we talk about eCal and the torque sequence, I will release you to put everything back together. Okay?
Perfect.